The next instruction of the PLC is related to the counters. Now in case of up counter, counters are basically those devices which are used to count various objects, like how many bags are moving on a conveyor belt or how many bogies are there for a train. Now for such applications, counters are used. There are two types of counters which are being configured in this programmable logic controller. One is called as up counter and the other is called as down counter. Let me first explain you how the configuration of up counter is done. For that, you will have to add rung. So go to add rung. So the rung is getting added at rung number 0. And I'll take one bit which is called as an initialization bit. This initialization bit is used as a counting mechanism for number of objects moving on a conveyor belt. Then we will add one up counter. The meaning of the word up counter is initially you will start with 0, then it will be incremented till it reaches to a preset value. This is called as up counter. For that up counter, there is an count up bit and there is a done bit. Now these bits are useful for the action. Let me configure this up counter. So configure, I'll give label as CTU and the preset value. For example, I want to count if two objects are passed on the conveyor belt. So this will be added as a preset value as 2. At present accumulator is 0 and let me configure this as a pulse. For example, this pulse I'll get from the optocoupler device. Now once I configured this, I can use this up counter for taking some action. For example, the action would be after transferring two objects on a conveyor belt, I want to switch on a lamp. That's my objective. Now for that, I will add one more rung which will indicate me that the two objects are being passed on a conveyor belt. So I take the bit, and then I will take the output. Now I can treat this output as lamp, which I want to configure this as indication of two objects are passed. So let me call this as lamp labeled, and this will be an indication of two objects are passed. Means once these two objects are passed, the done bit of up counter will be initialized or energized. So let me treat this as CTU. That's the semantics which you have to use, CTU underscore done bit, and I'll submit this. Now once I have configured this, then like previous case, compile and then run this. Now whenever I'm running this, now I want to simulate whether number of objects are passed and my up counter is working. Click on to the initialization bit and toggle the bit. The moment you toggle the bit, you will find here CTU-CU, that is up counter is up by 1, accumulator has become 1, but the done bit is 0 only. Now what I will do, the object have gone, so this will become 0. That means the up counting bit is not on, but the accumulator has remained 1 because one object has passed. Now if the second object goes like second, now you will find the second object has gone, CTU is on, accumulator has become 2, done bit is equal to high. Because of that, this done bit is high and the lamp is on. Now this clearly indicates that on that conveyor belt, two objects have passed. Now there is a typical requirement of the counter, unlike a timer. Timers are basically auto resetted. Either it is on delay timer or off delay timer. But in case of a counter, you will have to reset the counter, else the accumulator will go on incrementing. Let me demonstrate you this. For example, I have not taken any action, I have not resetted it. So what I will do is I'll toggle it once again. Look at this. This has become, done bit has gone, output has become 0, but accumulator has remained 2. Let me add the third object. If third object passes, naturally what will happen? The accumulator has gone to 3, it has crossed 2. So if I go on doing this, it will go on accumulating, and there is no purpose of using this counter for any operation. Now if you want to add the functionality of resetting the timer, you will have to add a reset bit. Let me do that. For that, you will have to go in development mode, add one rung, which is now rung number 2, add here a bit, and the most important thing is go to the counter, and you will find here there is a reset output or bit available. Put a reset bit here, and now what you will have to do is right click here and configure this reset. Please note down, this must be, the tag of this reset bit must be the same as the timer or counter label. Right here CTU, and if I tag here, now when do I want to do it is once the number of counts accumulator is equal to preset, means 2. So in other words, this label must be the done bit of the up counter. So I'll write here CTU underscore done. Now this is called as conditional resetting. Conditional resetting means once number of objects have passed, then and only it should get resetted. It's called as conditional reset. If I don't add anything here, every bit or every pulse, the counter will get resetted because there is no condition applied for resetting. Every time, every scan, it is resetted. Let me demonstrate you. So just have the compile it and run this. Now once you run it, look at this. I'll toggle this once. It has become 1. I will toggle this twice. So that means the second object have come. Now you will find the second object have gone. Now the done bit is not on, and the reason for this is indicated here. If I toggle this once again, look at this. This will become 1. It clearly indicates that after resetting it, it will start counting again. Now the question here is, if I don't get this reset pulse exactly after the reset, it will get resetted automatically. So this indication will be of no use for me. Hence, here is an assignment for you. Add and develop a logic which will give you resetting of the counter having some other condition. The present condition which I have used is the done bit. Instead of that, can you think of any condition which will give you after done bit, the lamp is on, but it is not resetted unless and until you force that condition. You can try it out this using the same compiler for programmable logic control.